Across Europe, drones are increasingly present in fields, forests, and rural communities, but their real impact depends on how innovation connects with the real needs on the ground. The Icaerus podcast series explores how this connection is built through research, use cases, and collaboration with innovators and end users across Europe. I am Dimitra Furkalidou from Reframe.food, and in this episode I am joined by Jurrian Doornbos, a PhD candidate at Wageningen University Research, where he conducts research on the development of a drone analytics platform as part of the Icaerus project. Welcome, Jurrian.
Hello, thank you, Dimitra.
So, Jurrian, let's start with the drone data analytics library. For those who might not be familiar with it, what exactly is it? How does it actually work in practice?
The drone data analytics library is a sort of a library, so just like books. But then instead of books, there is datasets, there's models, and that's datasets acquired from drones. Because drones can be used for anything. Mainly, there's a lot of monitoring tasks you can do with drones. And these are built on datasets, they acquire datasets, and these are processed using models. So it's like a library to look around and find datasets and models that work for your own use case.
Who do you see using this library the most, Jurrian? Is it mainly researchers or who else?
Yeah, so because it has been around for, I usually keep track of like 10 years or something that people use drones. It's been mostly researchers. We see, especially in the Icaerus project, that a lot of smaller sub-projects and a lot of smaller companies are using it as well. They always tend to have quite a nice amount of data, but not quite enough. So sharing all the data sets is also from research back to small, medium companies, and the other way around, that we can get data from them as well.
Okay, and these are already datasets and models that are scattered across the internet, but you have created something more central, more open and more accessible. What makes this library different from what is already out there, and what makes it unique in the end?
The main thing that we focused on is making everything open and available to anyone to access. So instead of needing to subscribe somewhere, needing to put your own data before you can get access to the rest, it's just out there. It's multiple websites. It's searchable, it's more findable, there's some metadata attached to every data set that we create. So it's just more accessible and free and open.
We have touched together the subject of open science, and it's a term that we hear a lot, especially in research and innovation spaces. But in practical terms, what does open science actually mean? Why is it so crucial?
Yeah, it's a bit more into the not very hard science, but it's more an opinion. What do we need it for? What do we like open science to be? From my perspective, it's that science tends to be very specific and very usable, although we miss sometimes a bit of the connection to the real world. I think open science tries to make everything that happens in these big European projects, or there's a lot of public funding, of course. It's to make sure that everybody can access what's being made and what's being imagined in universities as well. It's really as a public service. So you don't need to have your subscription to the different academic journals if you just process or if you just upload everything. No, the other way around.
Okay, thank you for making that understandable. Okay, great. And now if we zoom in on unmanned aerial vehicles, this is a field that is very close to real-world users like farmers or environmental managers, I guess. So how does open science change things in this context?
The way I see it is that the science is actually pretty close. We really want to use drones to see a disease in the field. We want to use them to identify, like count how the cows are doing. We want to check up on whether there are cracks in a bridge, for example. We want them to not really replace, but really augment current processes. And this is also where science comes in, so or where the research side comes in, because you have your time to figure out how to do it. There's these models being developed, and this is all happening in universities, but it's actually also happening in small businesses or bigger businesses that want to use drones, where these big data processing platforms are being developed. And then within research, we can sort of figure out or push what kind of models are available, and we're really close to what's happening on the ground. So if we figure out a nice way to do something, you really see it being used in the field as well.
Jurrian, sharing code, sharing data, being transparent even when things don't work is actually one thing, but what has made initiatives like this possible? And are there any challenges that still stand in the way?
The main challenges that still remain is trying to figure out where exactly drones fit, both in as like I said before, like monitoring and using it to get some insights. These are very difficult technical issues to get over. We see a lot of progress happening. There's a lot of research happening, of course, through different funding agencies. There's just public money. It's very important, but also trying to figure out the perfect utility for the drone. Not only regulations that are in the way for flying, for example, very autonomously, which I think the regulations themselves are fine. Make sure that we don't go too crazy in the automation. And then perhaps the things like further figuring out where drones can fit. I think a very nice example is in spraying drones, which you also have in the Icaerus project. And then spraying drones have a very nice utility in, for example, rugged terrain, where it's very difficult to go with a tractor, but you still want to very targeted approach to spraying in a field for pesticides or herbicides. And that's something that drones can really focus in on, and I probably see increasing as well as like a really nice application.
And if we look ahead a few years, how do you see the drone landscape evolving? The initial hype seems to have settled. Some regulations are tightening, and we are also seeing shifts influencing how drones are perceived. What changes would you personally hope to see?
I think with the drone use, we are seeing further specification. There are some companies that are using them. There's very strict regulations on how to use them to make sure that they're used within some sort of framework, and that's people are not just flying drones everywhere, which I think is a very good idea. These are very easy to use. They're very easy to annoy other people with, and I think being very strict and being very regulated on how and when to use a drone is, I think, a good idea. The drone perception is a different thing. Yeah, there's more people being aware of them, being annoyed by them, but also as maybe like a war machine. And the war in Ukraine, the war in Gaza, definitely has seen a lot of drone use. So now, instead of people thinking about their camera or like an extra camera for navigations, it's also this terrifying autonomous machine. Personally, I'd hoped everything to be more open. I'm especially with the library as well. We really see the nice applications of just sharing everything that's available. Drones also have a really big do-it-yourself section, so people are building them themselves and they're sharing how to do it and developing code and programs on how to do it. I think it will really even the playing field if everybody can have the same access to this. Whilst on the other hand, keep the regulations quite strict.
Okay, a bonus question so that we get to know you better. How did you decide to be part of this field?
I have a background in remote sensing, so that's where you use satellites. And there's these very annoying things with satellites that they're very expensive to run, but most of the data is free. And then there's all these limitations to the data where you have like, it's only the images can only see like to the specific resolution, so you can't really see very high details. And drones really are this new thing where you can see basically almost inside the plant. And you can see very extreme details, but you can also see it on a very large scale. So you can see your whole agricultural field, you can see the whole bridge, instead of either a small section of the bridge taken with your photo, with your camera, or the satellite image, which has all the whole surrounding as well. Drones are really this in-between thing where a lot of cool applications can happen, and they're nice to develop and work on. So that's got me excited for the project to join in.
Okay, Jurrian, thank you so much for joining us today and for walking us through the Drone Data Analytics Library and the broader vision behind it. We look forward to seeing how the drone ecosystem continues to evolve in the years ahead.
Yeah, thank you for your time and to develop the podcast a bit. Thank you so much.
For those watching or listening, this episode is part of the Icaerus podcast series where we look at how drones are being assessed and used in real agricultural and rural contexts across Europe. More episodes are already available, with new ones coming soon. Follow Icaerus on social media or visit the project website to stay informed. Thank you for joining us.